Okay, so the last discussion we have was on data types. So I just went on Google here, get an online C++ compiler. You could type it in Google search. And now we'll just go into declaring and initializing these different data types. So here on program it's like a template, right? A template main.cpp. We could run that. All right, it says try program is .pro. Okay, so here we have our preprocessor, we have our main function, and we discuss scope. So this is the scope of the main function, curly braces. Okay, so what we're gonna do is it's a int main function, so it returns 0, it returns value 0, and we'll discuss function the types of function later on. Okay, so let's work on declaring and initializing these different character types. So remember, we have these fundamental types, and character type is one category. So under character type, we have 4 types to declare characters. Okay, so to declare variables in C++, it's statically typed, so you have to state what you have to explicitly tell the function what value, right? So it's like allocating memory. So you're telling the compiler, this is the amount of memory I need. Okay, so you do char for character if you want to name the character. Camel case, my first char. And to declare character, single quotation. Okay, so A. Okay, and these are ASCII character. You could look that up. Okay, so the first one here is my first char. There's also a char 16t. So here, char 16t, if you look on the slides, it says it's not smaller than a char, but it's at least 16 bits. So char is typically 8 bits of memory, while char 16 is 16 bits. So it's just a little more memory, twice the size, right? So if we want char 16t, we do char underscore 16 char 16 underscore t. So you could say my first maybe 16 char. Okay, so 16-bit char, and we need a character for that. Let's call this L. Okay, and just remember, with C++, you need those semicolon to end your statements. Okay. All right. You also have char 32t, char 32 underscore t. Name of the variable my first 32 char, and we could name this. Let's name this x. Okay. So that's declaring chars, right? So now, what if we need to print? Oh, you also have wchar underscore t, which is the largest, right? So this is the largest supported character set. So if you do wchar underscore t, my first wchar. Okay, and then just set that equal to some, right? Because even numbers are part of the ASCII character set. And we could start print here. So we say print character variables. Okay. Okay. So to print, we have IO stream here. But let's say we didn't have IO stream. So this is the input-output stream. Okay. So if we didn't have that, well, we have we need the input-output stream. I'm sorry. What we don't have here is namespace standard library, right? So we could have using namespace std on the top, or we could reference the standard library, and you do that using two colons. Okay, so you say std standard library, and you're calling the cout. So instead of print, we do cout, and then to cout we do less than, and now we could print our value. So my first char. Okay, And then if you want to do an end line here, you do backslash, that's the escape key, /n. Okay. So if we look at how it runs here, it prints the A. Okay. So we have 1, 2, 3, 4. So let's copy this 4 times. Control C. Okay. And then let's update, right? So instead of we have my first char on the top, then you need my first 16 char, and then the other one is my first 32 char, and then the last one is my first W char. And if we run this, it'll print, right? But notice here, right? It prints. It doesn't print. Okay. So for my first char, it prints the A. Okay. The my first 16 char actually prints a number, and this is the ASCII representation of that number. So it's a numbering system that encodes to that character value. For example, here we could do, let's make all of these L's to show that they're same ASCII, right? So you get the ASCII values on these lower values. So here we could make a note, right? We could say these return of the character. So these return the ASCII encoding of the character. Okay, so this ASCII encoding is basically all the different symbols on your keyboard. We have printable symbols and non-printable. They're encoded to a value in your programming language. Okay, so that's declaring chars. Okay, we'll look at updating variables, right? Like let's say I declare my first char here, right? My first char here, and I need to overwrite. I could do this. I could just say, no need to redeclare, right? So we're just changing the value, updating. So we could say my first char here. Okay, let's see what's going on. Okay, my first char equal, and then change it to a new character K. Okay, and then if we print after this line, because coding, it's a sequential set of steps. So it did the printing, then you update. Now we could do another print and it will change that value to K. Okay, so we could copy this line up here. Okay, the standard library cout here. And you'll see that my first char will update to K. Okay, so now it's K instead of A. And so that's how you update a variable. Okay, so that's chars, character types. Okay, now we could look at signed integer, signed types, right? So you have signed integer types. But these integer types could be shorts, ints, long, and so on. So this is signed. So what's the difference between signed and unsigned? Signed mean that you have a plus or minus. So what it does is it divides the range in half. When I say range, I mean the allocation. It divides it in half. Give half of it here to negatives, half of it here to positive. However, unsigned is the full range. So it's usually positive numbers for unsigned integer types. Okay, so this one here is character types. So let's look at integer types. So if I go here, type integer types. So let's look at how to create these signed integer types. Let me put signed here as well. So right here. Okay. How do we declare signed? We remember statically type, right? So signed, signed. What kind of integer? Well, character. Well, this is signed character. It's not an integer, but you also have signed character. So you call this my first char. let's call this my first char, my first signed char. Okay, so my first signed char, and then it's gonna still be a character, but it's just that you've changed the allocation in memory, right? So now let's look at signed short. So signed short, and then you say my first signed short. Okay, and short values, if you look on the slides here, these short values here, they range. Let me go show you guys here. Find here. So this short value here has certain range. So signed short int, right? These are at least 16 bits. Okay, so short has 16 bits representation. And just remember, 2 to the bit size gives you the decimal, right? So 2 to the amount of bits. Okay, so it's a pretty large range, right? 2 to the 16. Okay, so short int. Let's make this 500. Okay, but if you go beyond the decimal range, you'll get error, and it'll say you're out of range for that allocation that you've made. Okay, so that's signed short. So let's do signed int. So signed int here. My first signed int. Signed int. The signed int is at least 16 bits as well. So let's do 100 here, and then do signed long. So long, you're allocating more memory, and long is 32 bits. So my first signed long. Okay, we could make this maybe 12,000 or something. All right. We also have long, more memory, 64 bits. Okay, so more memory. So why do we have these different signed integers? In real world, right, we could be working with very large number, right? For example, gravitational fields and stuff, right? Large planets. It depends on the application that you have. So we need these different types to basically to be flexible for the real world data that we're trying to insert into the programming, into the computer itself. Okay, so signed long. So my first signed long. We could set this to maybe 12 longer number. I'm not sure what that is. What's so that's 1.2 million. Okay. So now we could print, right? So let's print these characters. So how do we print? We need standard cout. So not characters, but print these print integer types. Okay. So standard cout. Okay. Now we need to print our my first char. So my first signed char. Okay. And then we probably need \n for n line, or you could type in n line, which is a part of the standard library. So do stand std cout again, and instead of my first signed char, we'll do my first signed short. So my signed short. Okay. Okay. And then instead of typing all of these, right, we could just copy. So we have 1, 2, 3, 4, 5, right? So we could copy this twice here. All right. And then copy one more. And then delete this one. All right, so here instead of so we have my signed short char short, my first signed, this one should be int. All right, the other one is a long, and you can see the benefit of doing camel case, right? So it's not really taught, but it helps in terms of writing code a little faster. Okay. So since we've done the character types, let's comment out the code. So control slash, and then see if these prints. All right. So I got some error here. My first, yeah. So spelling error, line 32. My first signed. What's that? My first sign. Yeah, so I have some spelling error here. My first SIGNED. So line 32. Okay. Remove the S. Okay. And there you go. You have all these different sign types. Okay. There is a function in C++, and it's called the type ID function. So let's look at this. I know we don't cover function yet. Just view it as another, just view it as an operator, right? So you have this type ID thing, right? Where you can wrap these variables in, okay? So you have type ID, and if you do type ID dot name, so let's say type ID the variable name, so I will call that var name, and if I do a dot name on that, it will return the type ID of the variable. Okay. We might not use this a lot in statically typed language. In Python, you have the type operator, but in statically type, we already know the type that we declare. So that's the good thing of statically typed language. You have to know the type that you need for your problem beforehand. So it's like one extra level there versus dynamically typed language. So what we'll do to use that type ID there, we'll take these print statements here, right? And we'll copy them down here. And we'll wrap, let me see if alt works here. No, let's do shift here. Shift. No. Control here. Okay, so we'll wrap all of these in the type ID function. But to get the type ID, I have to import type info. I know it's getting a little technical here, but just follow along for now, right? So type ID, we do type ID here. Wrap, okay, and then we go. I might need, so yeah, escape that. So just wrap this type ID, and it'll return the type ID for all these different values here. Why do we need it? Maybe we need it in some algorithm, right? So if this variable is of type ID here, carry out this operation, okay? So type ID, okay, so here, all of these, control that one. We need a dot name, okay? So for now, again, just view it as this thing that you do with variables. I know you might not, first time declaring variables, first time coding, okay? Just view it as this operation that you could do with the variables. All right, so the next thing that we need to do to use the type ID, we do pound include type info. Type info from the library. Type info, okay? And this will give all the numeric types inside, all the signed integer types inside C++. So it will give you the type ID. Okay, so here we'll see the type ID. So A is for character, signed character. S is for signed short. I is for signed integer. L is for signed long, and X is for signed long. Okay. So the next part here is unsigned, right? So instead of signed, we could do unsigned, and I'll pick up on unsigned and the remaining. So those are the signed versus unsigned, and then we'll go on to the floating points, right? So after that, we'll go to floating points types. Okay. So for now, we could stop here. Unsigned. We'll do that along with floating points in our next video. Okay. Thank you for watching. Hope I'm imparting something here. Okay. Thank you.